We're going to solve the equation e to the x minus e to the minus x over 2 equals 7. First of all, I noticed that my x variable is in the form of a fraction, and I can conveniently get rid of this fraction, so let's go ahead and do that so we can make our later steps a lot simpler. To do this, we're going to want to get rid of the denominator 2 on this side, so therefore we should multiply both sides of the equation by 2. Then we're going to have e to the x minus e to the minus x equals 7 times 2, which is 14. Now next we want to construct some kind of equation that we would know how to solve, because as is, there's no way that we could solve this that we know of currently. However, we do know how to solve a quadratic equation, so therefore we're going to have to find a way to make this look somewhat like a quadratic equation. Now to do that, I would suggest that we multiply each side by e to the power of x. So let's go ahead and do that. So we're going to have e to the x multiplied by both of these terms equals 14 times e to the x. Now since we've got the e to the x in this bracket, we're going to distribute e to the x to each of these two terms. So then we would have e to the x times e to the x. And since they're the same base e, when we multiply them, we add the exponents. So we'll have e to the 2x. Here, e to the x times minus e to the minus x. Again, same base, so we're going to add the exponents. Plus 1 plus minus 1 is 0. So we'll have e to the 0 equals 14 e to the x. And here I'm going to change this e to the 0 into a 1 because any number to the power of 0 is 1. So now we've got e to the 2x minus 1 equals 14e to the x. And now I want to move this 14e to the x over to the left side so that I've got one side equals to 0. So let's have e to the 2x minus 14e to the x minus 1 equals 0. Now you might be looking at this equation and thinking that maybe it looks unfamiliar. However, if I rewrite this equation with a different variable, like say a, we'll have a squared minus 14a minus 1 equals 0. This should look extremely familiar to you, as this is just simply a quadratic equation. But we've substituted the e to the x as a, so therefore the e to the 2x would become a squared, and 14e to the x would become 14a. And now to solve this quadratic equation, I've got a few different ways. I've got factoring the quadratic formula and completing the square. I always look to see if the quadratic is factorable first before I try the other methods, as it is the fastest way. It looks like this quadratic is not factorable because there's no possible two numbers that could multiply to give me minus 1 and add to give me minus 14. So I'm going to try and complete the square. To complete the square, we look at this middle number, the minus 14. We're going to half the number and then we're going to square it. So minus 14, half of that is minus 7, and then the square of that is plus 49. So I want to make this constant minus 1 here a plus 49, because once I do that, I can then factor out this quadratic. So we'll have to add a number to this constant to make it plus 49. So we're going to have a squared minus 14a minus 1 and plus 50, because plus 50 minus 1 is plus 49. And because we've added plus 50 on the left side, we also add plus 50 to the right side. And we'll simplify this. a squared minus 14a plus 49 equals 50. And then we can go ahead and factor this now. So we'll have a minus 7 squared equals 50. So now that we've reached this point, the purpose of completing the square is so that if we've got a minus 7 all squared equals 50, then we must be able to square root this side and this side, and the equation will remain equal. So therefore we've got a minus 7 because we've square rooted this and square rooted this. And then we've got plus or minus square root of 50. And now we want a on its own. So we move this minus 7 to the right side, have plus 7 plus minus square root 50. But don't forget that we only use this a as a substitute for e to the power of x. So now would be a good time, since we have a on its own, we can change this back to e to the x just so we don't forget later. Now we look to simplify this radical here, this third, square root of 50. We can break that down into 25 at 2. And the square root of 25 is 5, so simplify. 7 plus minus 5 and square root of 2. And now we want the x on its own, so to do so we should take the log of both sides, or the natural log of both sides, so that we have ln e equals ln e to the x equals ln 7 plus minus 5 root 2. And then we can use the property that allows us to move this x into a factor. And this ln e is, of course, just 1, so we'll have x equals ln 7 plus minus 5 over 2. And now we must pay attention because the domain of the ln function is only all positive numbers. And you should notice that 7 minus square root of 50 would be a negative number, because square root of 49 is 7, therefore square root of 50 must be some number a little bit higher than 7. So we don't want that, which means that our final answer is going to be x equals just ln 7 plus 5 root 2. Hopefully you found my guidance for today's question useful. I upload questions like these every single day at the same time, so if you enjoyed them, leave a like on the video and subscribe to my channel. If you have any of your own questions, leave them in the comments and I will get to them. See you next time.